NENOMATICA, where mathematics meets YouTube excellence. Welcome. In this lesson, we will verify Lagrange's identity step by step and then apply it to a concrete expression. We will also highlight each algebra move clearly. First, let's display the example prompt and the problem statements in bold orange math. Step 1. State the identity. Lagrange's identity says, left parenthesis a squared plus b squared right parenthesis times left parenthesis x squared plus y squared right parenthesis equals left parenthesis ax plus by right parenthesis squared plus left parenthesis ay minus bx right parenthesis squared. Step 2. Expand the right-hand side. We expand the first square. Ax plus by, quantity squared, which gives a squared x squared plus 2, a bxy plus b squared y squared. Then expand the second square. A y minus bx, quantity squared, which gives a squared y squared minus 2, a bxy plus b squared x squared. Now combine like terms. Notice the plus 2 abxy and the minus 2 abxy cancel. Step 3. Group like terms. Factor the x squared terms together and the y squared terms together. Step 4. Factor out the common factor a squared plus b squared. This yields left parenthesis a squared plus b squared right parenthesis times left parenthesis x squared plus y squared right parenthesis, matching the left-hand side exactly. Lagrange's identity holds. Now, let's apply the identity in an exercise. Step 5. Rewrite each factor as a sum of squares. 4 squared is the same as 2 quantity squared, and 9y squared is the same as 3y quantity squared. Step 6. Apply Lagrange's identity directly with a equals 2a, b equals b, x equals x, and y equals 3y. The result is left parenthesis 2, ax plus 3b, y right parenthesis squared, plus left parenthesis 6, a y minus bx right parenthesis squared. Welcome to Lagrange's identity. It is a beautiful algebra and geometry bridge. It says, the product of the squared lengths of two vectors minus the square of their dot product equals a sum of squares built from little 2 by 2 determinants. We will see the general identity, a geometric picture, and a numeric check. Here is the general form for n components. Let us interpret the pieces. This factor is the squared length of vector a. It is a sub 1 squared plus a sub n squared. This factor is the squared length of vector b. This is the dot product of a and b, all squared. And this sum runs over every pair I less than j, squaring the 2 by 2 determinant a sub I b sub j minus a sub j b sub I. So Lagrange's identity says, length of a squared times length of b squared minus the dot product squared equals this sum of squares. In 3 dimensions, Lagrange's identity becomes a famous vector identity. Norm of a square times norm of b squared minus the dot product of a and b squared equals the norm of a cross b squared. Geometrically, norm of a cross b is the area of the parallelogram spanned by a and b. Let's build the picture. Think of the area of this parallelogram as norm of a times norm of b times sine theta. That area equals the norm of a cross b. So the square of the area equals the square of the cross product norm. By the Pythagorean identity, sine squared equals 1 minus cosine squared, and cosine theta is the dot product divided by product of norms. That algebra turns into Lagrange's identity in 3 dimensions. Now, a concrete numerical check in 3 dimensions. Let it equal the vector with entries 2, -1, and 3. Let b equal the vector with entries 1, 4, and 0. We will compute both sides and confirm they match. First, the left side, norm of a squared times norm of b squared, minus the dot product squared. Norm of a squared is 2 squared plus -1 squared plus 3 squared equals 14. Norm of b squared is 1 squared plus 4 squared plus 0 squared equals 17. The dot product is 2 times 1 plus -1 times 4 plus 3 times 0 equals -2, and the square is 4. So the left side equals 14 times 17 minus 4 equals 234. Now, the right side with the 2 by 2 determinants. We take all pairs I less than j. 4i equals 1, j equals 2, 2 times 4 minus -1 times 1 equals 9. Square gives 81. 4i equals 1, j equals 3, 2 times 0 minus 3 times 1 equals negative 3, square gives 9. 4i equals 2, j equals 3. Negative 1 times 0 minus 3 times 4 equals negative 12. Square gives 144. Adding them. 81 plus 9 plus 144 equals 234. The cross product also fits. Norm of a cross b squared equals 234. Let us show the cross product vector for completeness. Summary. Lagrange's identity says, product of squared lengths minus dot product squared equals a sum of squares of 2 by 2 determinants. In 3 dimensions, it equals the square of the area of the parallelogram, the cross product magnitude squared. It underpins the Cauchy-Schwarz inequality, connects algebraic minors to geometry, and explains why the cross product measures area. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.